Hi everyone. Our group, which consists from Vladimir Keberes and myself, Natalia Chapraga, will present our research project that is about cars of different companies from different countries. We used SAS program for our statistical procedures, and we will present it in the next slide. As future buyers of a car, it is essential to have an understanding that there are multiple variables that affect MSRP of a car, such as the size of the car, the amount of number of doors, the engine size, etc. Based on the study from the Statista, we learned that the United States' most popular brands originate from Germany, Japan, and the United States. In our research, we computed different types of statistical procedures to better understand what kind of factors will affect the MSRP. We computed a correlation coefficient test between different variables to see if the elements are significantly different based on the car's origin. Our analysis can make some suggestions on what kind of a car a customer should purchase based on his or her preference. In our research, we created a model that can predict the MSRP based on different variables, which we will talk in the next slide. The original data consisted of 11,914 observations. Out of these 11,914 observations, we randomly selected 4 brands from Germany, Japan, and United States, which are the most popular in the United States market. We computed different types of procedures to better understand what kind of elements cause the increase or the decrease in the MSRP. We created a new variable that shows the brand of the car and to which country it belongs. For example, BMW would show that it belongs to Germany. The dataset contains 953 observations for the year of 2017, 9 qualitative variables, which are, as we can see in the slide, the make, the model, origin, engine fuel type, transmission type, driven wheels, market category, vehicle size, vehicle style, and 7 quantitative variables, which, as well we can see in the slide, is the engine HP, engine cylinders, number of doors, highway MPG, city MPG, popularity, and MSRP. The purpose of test number 1 is to test the hypothesis if the cars have different MSRPs for Germany, Japan, and US origin. For this test, we use the variables origin and MSRP. The HO hypothesis is mu1 equals mu2 equals mu3, meaning that the mean for Germany, Japan, and USA cars are the same. The H1 hypothesis is at least one of the origin means is different from other origin means on MSRP. Based on the findings from the Levens test, we are rejecting HO hypothesis since our p-value is less than our alpha, which is 0.05 for the test. Therefore, we can conclude that at least one of the means for the origin is different from other means. In the SNK table that we can see in the slide, we can have a better visualization for the findings that the means for USA and Japan cars are relatively similar, and the Germany cars have a different mean. The purpose of test number 2 is to use statistical procedures to determine if the means for the origin are different between each other with a condition number of doors. The variables used are origin, number of doors, MSRP. In this test, we have 3 different hypotheses. For the first one, we have HO, there is no interaction between MSRP between origin of a car brand and numbers of doors. H1, there is interaction between MSRP between origin of a car and number of doors. The hypothesis number 2 is H0. There is no difference in the means for numbers of doors on the MSRP. H1, there is difference in the means for numbers of doors on the MSRP. Hypothesis number 3, HO, there is no difference in the means for origin of the car brand on the MSRP. H1, there is difference in the means for origin of the car brand on the MSRP. Based on the findings from F-test, we obtained a p-value which is significantly lower than our alpha for the 3 hypotheses. Therefore, we will reject all HO hypotheses for this test. Based on the F-test results, we can conclude that there are interactions between the number of doors and car origin. Another assumption from the test results is that there is a difference in the means for the number of doors on the MSRP. Lastly, we can conclude from the F-test results the car's origin is different on the MSRP. Additionally, the results from the Tukey test supports our conclusion. There are many combinations that are rejecting HO hypothesis. In the Tukey test, if we are to read the combinations, which we can see in this slide, we can see that one of the combinations, which is 1 and 2, rejects HO hypothesis. Also, there were small numbers of instances where HO hypothesis was true. The purpose of test number 3 is to test if there are any correlations coefficient with each variable with MSRP. For this procedure, we used all quantitative variables to MSRP. The hypothesis is HO rho equals to 0 for variable MSRP with other variables. HA rho does not equal to 0 for variables MSRP with other variables. Based on the results of the test, we can see the p-value is significantly less than alpha for all variables. Therefore, correlation exists between MSRP and all quantitative variables. From the test results, we can see the highest correlation exists between MSRP and engine HP. It has 0.77 positive correlation, meaning that if the HP engine increases, then the MSRP will also increase respectively. Engine cylinder has a positive correlation. Now, the number of doors, highway miles per gallon, city miles per gallon, and popularity have a negative correlation. Now, I'll pass it to Vlad to present the remainder of the presentation. Vlad, please go ahead.
Thank you, Natalia, for the introduction for our group. The purpose of task 3 is to test if there is correlation coefficient exists between variables MSRP and engine horsepower. For this procedure, we used variables MSRP and engine horsepower. The hypothesis for this test is HO beta 1 equals to 0 between MSRP and engine horsepower. H1 beta 1 is not equals to 0 between MSRP and engine horsepower. Based on the regression test results, we can conclude that there is a slope between those two variables. Our p-value is significantly less than our alpha, which is 0.05. Therefore, we will reject our HO hypothesis. To better understand our findings, we have created a regression line model which indicates if the horsepower of the engine goes up, our MSRP for the car will increase respectively. In other words, they have positive correlation. In one of our tables, we can see R square. This number represents that 59.65% of the test results can be explained by this regression model for those two variables. The purpose of test 4 is to use a two-sample t-test to determine whatever miles per gallon on a highway of the two and four-door cars are significantly different. For this procedure, we used variables number of doors and highway miles per gallon. Hypothesis: HO, highway miles per gallon for two-door cars is same as for the four-door cars. H1, highway miles per gallon for two-door cars is not the same as for the four-door cars. From the test results for equality of variance, we can see that our p-value is significantly less than our alpha. Therefore, we will reject our HO hypothesis. In other words, we are concluding that there is a difference in the variance between those two groups. In the next testing, we used Satterthwaite method since we rejected our HO hypothesis for the equality of variance. In this t-test, we can see that our p-value is significantly less than our alpha. Therefore, we can conclude that there is difference exists in the means for the cars with different number of doors on their fuel efficiency. The purpose of Test 5 is to create a model that will best suited to predict the MSRP for the car using different types of variables. In addition, we will test if at least one beta is not equal to 0 using the stepwise method. We used variables MSRP, engine horsepower, engine cylinders, number of doors, highway miles per gallon, CT miles per gallon, and popularity for this test. Hypothesis for this test: HO beta 1 equals beta 2 equals beta 3 equals beta 4 equals beta 5 equals beta 6 equals to 0. And our HA hypothesis is at least one of the beta is not equal to 0. From the stepwise method results, we can see that at least one of the betas is not equal to 0. In the test, we can see that our p-value is significantly less than our alpha. Therefore, we will reject our HO hypothesis. The stepwise method shows us the best model that can predict the value for the variable MSRP. We can see that variables engine horsepower, highway miles per gallon, popularity, engine cylinders, and CT miles per gallon can explain 64.63% of the MSRP in the step 5 of the stepwise method. The purpose of task 6 is to compute the chi-squared procedure to see if there are similar properties between number of doors and vehicle size. The variables used for this procedure: number of doors and vehicle size. Hypothesis: HO. The properties between the number of doors and vehicle size variables are equal. HA. The properties between the number of doors and vehicle size variables are not equal. From the chi-square testing, we can see that our p-value is significantly less than our alpha. Therefore, we will reject our HO hypothesis and we can conclude that properties between two-door car and four-door cars are not the same. In the chi-squared table, we can see that 17.84% represents cars with the two doors and 82.76% represents cars with four doors. The purpose of task 6 is to test the hypothesis. If the number of doors increases, will it cause the vehicle also to increase? The variables used for this procedures: number of doors, vehicle size. Hypothesis: HO. The number of doors is not increased with the size of the car. HA. The number of doors increases with the size of the car. Based on the chi-square test results, we are rejecting our HO hypothesis, since our p-value is significantly lower than our alpha. Therefore, we can conclude that if the number of doors increases, the size of the vehicle will also increase. One of the examples from the chi-square table that can support our conclusion is comparison between two-door and four-door cars with the size compact. We can see that 7.97% represents two-door cars of population with that element, and 22.77% represents four-door car with that element. In other words, this table shows that if the car has more doors, then a larger vehicle will be. Based on the various statistical procedures, we can conclude that many factors cause MSRP for cars to change. In the research, we identified that German cars have relatively higher MSRP than cars that originate either in USA or Japan. The MSRP for USA and Japan manufacturing cars companies is relatively similar. Another procedure supporting the statement is two-way ANOVA procedure, where we compared different car manufacturing companies to the MSRP. It shows that there is a significant difference in the means for a region of the car make. In the next part of the research, we compared the correlation between variables MSRP with other variables in this sample size. We were able to reject our HO hypothesis, therefore we can conclude that there is a correlation between MSRP and other variables. Some variables add a strong positive correlation and others add a negative correlation to the MSRP. In other words, when future buyer compares different car models that he plans to purchase, he or she should remember that several variables can predict the MSRP for a particular vehicle. Next, we compare the variables with each other. Based on our findings, we can conclude that each variable correlates with each other. The only variable that failed our statistical procedure was popularity. In other words, popularity does not correlate with other variables to behave differently. In the next statistical method, we have compared the means for two-door and four-door cars on the highway miles per gallon. Our findings suggest that there is a difference between two-door and four-door cars on fuel efficiency, and a future buyer plans to save money on highway trips, they should consider choosing a vehicle with two-door instead of four-door. To better predict MSRP for a car, we have computed a model using a stepwise method. With the procedure, with the model, we can explain 64.64% of MSRP of the data. In the last part, we use chi-square procedure. Based on our results, we can conclude that properties for the vehicle size and two doors are not equal since we rejected our HO hypothesis. In addition, we proved that if the number of doors increases, our vehicle size will also increase. Those findings should give some suggestions to the future car owner what kind of variables or causes MSRP of vehicle to increase or decrease. Thank you so much.